Second lab, you'll do the insertion part, where you are actually you'll have an interface for a user to enter in a new album into the database, and you'll have to write the JDBC code to do that. So today we don't have much left on JDBC. So today, for the rest of today, we'll finish that up, but then we'll briefly talk on multi-tier architecture, which is also secretly what this lab that you did yesterday and the next lab are doing, because there is actually a model view controller kind of architecture there. You deployed to a web server, and there was a front end, which was done in JavaScript, HTML, CSS, whatever. There was a middle tier, that was the Java stuff that you were working on. And then there was a database tier that we already did for you by creating the album databases to begin with, and that you installed. But before we get there, let's talk a little bit about best practices for JDBC. Not necessarily best practices, but my suggestions to make your lives easier as well. The first one is dealing with SQL exceptions. You might have noticed that every single piece of JDBC code that had to be surrounded with this try-catch statement for these SQL exceptions. And that's because they're checked exceptions, meaning that in Java, you have to surround them with a try-catch, and you have to deal with them. Well, like with most checked exceptions, I prefer not dealing with them because there's really not a way that you can recover from a generic SQL exception. First of all, it's way too generic. Why did it fail? Did it fail because our query was bad? Did it fail because we don't have a password? Did it fail because we didn't have a network connection? There's no granularity there at all. Any one of those issues could throw an SQL exception. And any one of those issues we cannot reasonably recover from. So it is simply best. It is best to catch and release. Right? In other words, again, as we discussed when we first covered Java, that you're simply going to you'll have to surround everything with a try-catch, right? Potentially dangerous JDBC code here, right? And then you catch an SQL exception. I'll just call it E here. And you caught it, fine. Now you need to release it. And to release it, I'm just going to throw it back. Throw new runtime exception. And I'm going to wrap E around up in that. And the consequence that this has is it preserves the stack trace, it preserves the exception, but it changes it into a runtime exception, which means that it's no longer a checked exception, so you don't have to worry about it catching it at a higher level in the program. Exceptions, when they're thrown, either they'll travel up the call stack until somebody catches them and deals with them, or until it gets all the way up to your main and then kills the Java virtual machine, which is exactly what you want. If you didn't write your syntactically correct SQL, there's no way that you can recover from that. That should be a fatal error. You go back to the drawing board, you fix your queries, and then you redeploy. Right? So that's how you can deal with all those SQL exceptions. The other one that I never cover blind statements in here. Always, and I'm putting that in big quotes there, always use prepared statements. All right? This goes for any programming language whatsoever. There are statements, and then there are prepared statements. Prepared statements actually sanitize your input. All right? In general, strings may contain dangerous SQL code. Oh, SQL code. Dangerous SQL code. And I'll show you that. Well, you actually already seen the example, little Bobby tables, right? Somebody posted the XKCD of that. You have to sanitize your input to protect your database and application, right? And to see what I mean by that, I'm just going to go ahead and go to the slides here that were pre-prepared and that are available in the videos, by the way. So take a look at this code right here. Say that. Oops, sorry. So say that we have a web form, right? And we ask a user to enter in the last name. And this user is a malicious user that's trying to probe our system to see if we're sanitizing our input or not. And in our code, we don't use a prepared statement. Instead, we use simple string concatenation to insert that last name. So select, or in this case, select primary email from user where last is equal to, and now I'm putting those single quotes inside the string, but then I'm concatenating that last name. Now, if somebody enters, Johnson, Burke, whatever, then there's no problem here whatsoever. But to probe a system, what if somebody enters in A and then an apostrophe, then a semicolon, ending that query, and then adds their own query as part of their last name, drop table user. Well, what ends up happening is that you have this this string now. Select primary email from user where last equals blah. That ends the query, and then drop table user. Now, if you don't have a very sanely set up database that doesn't allow multiple queries, then say goodbye to your user table now, right? It was running in your application. Your application ostensibly had permission to go ahead and execute queries on the server. And by not sanitizing your input, you are allowing somebody from the outside to inject their own SQL code into your code base. This is a classic SQL injection attack. You can inject your own code into another person's system. Now, there are lots of ways around this. The easiest way around to protect yourself against this is to simply always use a prepared statement. Because a prepared statement will go along and see, oh, an apostrophe? Oh, I need to escape that for you. And then it escapes it for you. And now it's no longer ending that other string, right? And now it's just one. Now it's two queries, may or may not work. But it is taking this literal string right here as the first name. Okay. There are other things that you can do to protect yourself. A sanely set up database will not allow multiple queries, right? It's kind of like safe mode in MySQL Workbench. It wouldn't allow us to do certain things. It wouldn't allow us to shoot ourselves in the foot. And mostly, for the most part, more modern databases have a default setting that don't allow you to do this. You have to actually go in and change the settings so that you would allow something like this. Right? And this is a classic SQL injection attack. If you're interested, on your next lab, do the advanced activity. We walk you through how to do an SQL injection attack, right? And against your own database, of course. And of course, you've seen the comic before, Little Bobby Tables. They named their student an SQL injection here. I've seen this many times. Programming contests, there's always some team that names themselves some sort of an SQL injection attack to see if the programming contest people set up their database correctly or not. Right? That's available on the website too. It's XKCD. Right? And I don't want that big anymore. There we go. All right. So always use prepared statements. Prepared statements, or statements, in Java, sanitize the input to protect your system against SQL injection attacks. Right? Always, always, always use prepared statements. So much so that I don't even cover raw statements. Moreover, there's also generally a misconception that prepared statements are somehow less efficient, but that's actually less true. Prepared statements are actually more efficient for batch operations. And what I mean by that is, say that you want to insert 50 records, and you want to do it one by one. Well, you can prepare the statement once, and those question marks, those can be reset, right? So for each one of your 50 records, reset those the question marks without having to re-prepare the statement, and then execute that 50 times. It's actually more efficient for batch operations, or it can be at least. Right? Next good practice tip: always avoid the star operator. Right? If you did this, select star from, I don't know, user, or whatever your table is, right? Don't do that. Oops, sorry, there we go. There, now it's highlighting, right? Don't do that. Again, it requests everything even if you're not going to use it, right? It sends unnecessary information, data across the wire, right? Reducing your overall bandwidth and throughput. If you end up ignoring it, at the other end, you've wasted network resources. Network resources, right? So don't do that, right? Now somebody did point out on Piazza the other day, well, wait a second, there's redundancy when you do your joins, right? When we did that join from the video game database, right? When we just selected everything and it displayed in MySQL Workbench, there was a lot of repeated data there. One publisher could have 10 games, right? And that publisher name was repeated over and over and over again. I'm not sure, but depending on the driver, it may be more efficient than that. Like, it's not sending 10 copies of that same string over the wire. It's only sending one, and then there's a reference back to it for each one of the other ones. So it's not actually sending may not be actually sending redundant information over the wire. So that's not that big of a concern. Now, maybe some drivers don't do that, but those drivers need to be improved if they're not doing something like that. All right? So make sure that you are not using the star operator to request other things. Also, if the database is changed, then you are pulling information that you are definitely ignoring. So be more intentional. This goes for every programming endeavor. Every single piece of code that you write should be done intentionally, right? It shouldn't just be haphazard. Yeah, I'll throw that in there. Or dead code, I'll leave that in there. Or I'll do this other unnecessary operation. Oh, it doesn't matter. Everything should be intentional. You should have, every single line of code should be something that you understand and that you want to be there, right? And that it has a purpose. If it doesn't have a purpose, it's just cruft. Do you remember that word, cruft? From C-R-U-F-T from last semester. It comes from, I don't know, Harvard or MIT, wherever Cruft Hall is, right? The story so goes that Cruft Hall was this hall that they used to hold classes there, and then it became a hall where you dumped old equipment that you no longer needed, right? And we probably have a Cruft Hall somewhere. Every department probably has some Cruft area where they just throw the junk that they no longer need until somebody actually stands up and says, well, no, we need more room here. We need to actually take this to the garbage, or we need to take it to procurement and give it back to them so that they can sell it for garbage, right? And that does happen. There are, I think, monthly or quarterly auctions on, I don't know where they are anymore, but you can buy like 50 used chairs if you want, or CRT monitors if you really want, right? So don't leave cruft in there. Don't leave junk just because I wrote it, so it must be okay. Just leave it in there. Get rid of your cruft. Everything should be intentional, okay? Some additional issues. Oops, sorry. Additional issues, right? Security, right? Security should, access should always be minimal, right? So if you were writing a program that simply went to the database, pulled out information, and then displayed that information to the user, you were never writing to the database, then you should probably create an account that has read-only access to that, or better yet, create what's called a view. In the database, you can create a view, which is a fake table. You basically write your query, and then you create that as a view that can return exactly what you want to give them. It's only a view. It's not a real table, so they can never insert or update or destroy anything in that view, but you can give them read access. And if all they need is read access, then that's all you should do. Even if you control the database, even if you control the application, you might want that separation of responsibility. The code over here that is responsible for reading stuff, we'll set that up with one account. The code over here that's responsible for writing stuff, we'll set that up over here with another account. So that we're assured that I'll never put an update statement in the code base that is responsible for just pulling data, right? Security access should always be minimal. You should use views or trigger views when called for, right? And again, we're not going to cover views, but I'm telling you that is an option. Never store sensitive information in a database unencrypted, right? This goes especially for passwords. Never store a password in a database unencrypted. Never store a password in a database using a terrible encryption, cryptographic hash function. A classic example is going to be MD5. That's one of the most commonly misused hash functions ever. And the reason for it, you can directly blame PHP for this. PHP put MD5 as basically a native function. So hey, there's a cryptographic hash function. Let's use it, right? MD5 has been broken for a while now. It was never intended for password hashing. Instead, you need to use something better like PBK DF2, which is password-based key derivation function version 2, where basically you want to slow down an attacker. Even if your password, the hash password is released, you want to make sure that it takes as long as possible for them to attack that password. And the way that you do that is through a PBK DF2 function, or a script or bcrypt or something like that, that doesn't just hash it once. It hashes it 60,000 times. Now, it might take a second or two to actually hash it, and so when you're logging in, yeah, you pay for a second or two to check the password, but if you have to do this over and over and over again as a hacker that's trying to break a password, then those seconds start to add up. And now you've slowed the hacker down. Security is always security is never perfect. Security is always an arms race between those who want to break systems and those who want to protect systems. And those who want to protect systems can only ever slow somebody down, right? Any padlock can be broken. As long as you have big enough cutters, right? Any encryption thing or encryption standard can be broken given enough time. The whole point of encryption and security and all that stuff is to slow attackers down. Ideally, slow them down so that it takes centuries for them to break your encryption. And that's what real encryption algorithms are all about. So never store information unencrypted in a database. You hear about it all the time. I forget what the most recent one was, but you hear about it all the time that thousands of passwords were compromised, and then you hear, well, wait, what encryption standard did they use? Oh, they used MD5, great, and there was no salt, great. Well, now all those passwords are probably going to be broken, right? Or at least a good chunk of them in order for you to exploit those logins. By the way, assault is a protection against a dictionary attack. So what are the most common passwords? Well, you can look it up. Just type in Google. What are the most common 10,000 most common passwords? And there are files out there with broken passwords that people use. What's the most common one? What do you think? Password, exactly. What's the second most common one? 1, 2, 3, 4, 5, 6, 7, 8, or however long you require them to enter it, right? And those are terrible passwords, but they're also very, very common. Another common one is admin or guest or root or things like that. And so what you can do as a hacker, if you want to break passwords, is you can pre-compile all these lists of used passwords, or just take the dictionary and then pre-compute all of the hashed passwords. And then when you break, then when you get a candidate password as a hash, all you have to do is look through the ones that you've already generated. Oh, I found it. Well, their password corresponded to this dictionary word over here. That's called a dictionary attack. Those are called rainbow tables because you can look things up. You can look up broken passwords that way. But the way that you protect yourself against that is by adding a salt, right? What is hash, by the way? What is hashing in real life, in just plain English? Think of your breakfast. What do you eat at breakfast sometimes, maybe? Hashing is chopping up, and that's what a hash function does. It chops up a domain into a codomain. Don't worry about that technical detail, but basically it's a hash. Well, if you want to make your hash browns taste better, what do you do to them? Put a little salt on them, right? And so in the context of a password, what you're doing is, here's my password. The system supplies a salt, which is just a random number, right? So every time I enter my password, I'm just entering this password, but the salt is stored, concatenated to this, and then that's what's hashed, or some mechanism similar to that, right? And then once that's hashed, then now I've completely blown away all of those dictionary attacks, all those rainbow tables, because they would have to regenerate all of those things given the salt over here, right? And that's a way that you can protect very, very simple security mechanisms that are unfortunately very, very commonly forgotten, right? Some efficiency issues. Right? I'm going to repeat myself. Always close your resources. Right? Again, did anybody run into an issue yesterday where they were not closing their resources and they suddenly had 30 persistent open connections and the 31st one died? Anybody want to admit to that? No? Okay. Well, then you are following my instructions and you closed all your resources. In addition, you can use more advanced techniques like connection pools. So the idea with connection pools is that you can actually open up, say, 10, 20, 30 persistent connections and then leave them open. Keep them alive for the life of your application. And the reason that you would want to do this is because that initial connection, that handshake with the server, the authentication, the back and forth of, yes, we're talking to each other now, that's one of the most expensive things you can do. So let's just go ahead and open up 30 connections, only do that once. Put them into a pool, and now anytime you need a connection, instead of creating a new connection, you go to the pool and say, please give me a connection. It's kind of like checking out checking out a book from the library. Oh, here the pool has a connection. Here you go. Go ahead and use it. When you're done with it, you don't close it. You put it back in the pool so that other things can use it, right? And this is especially true in a multi-threaded environment where you want to open up a bunch of connections and different threads can use them. You're not writing any multi-threaded programming in your project, so there's no reason to use a connection pool, but you could look into it. Generally, you want to use a library to do it. And one of the de facto libraries for Java is called C3PO. It's a connection pool that you can use. It's also used in, I think, JPA, or at least some implementations of JPA. Now there is an issue here, right? What if you go to the pool and there's no connection available? Well, you have to design the pool such that it blocks that thread and says, no, wait, go to sleep. I'll wake you up when I have a connection, right? And then, so it does require some multi-threaded programming. But if you're using a proper library to do it for you, then you generally don't have to worry about that. Good normalization generally gives you very, very efficient performance. Right? I can't tell you the number of times that I've seen a terribly performing database, and then I go to look at the actual schema, and oh, hey, they don't have any primary keys. They don't have any real foreign keys. There's no indexing whatsoever. The reason that we index things, like primary keys, if you want to search by a primary key, it's generally indexed. Indexing is nothing more than a fancy way of saying that we're going to sort them, right? Now, it's not exactly like this because it's using some data structures, but remember last semester, when you sorted something, what became suddenly efficient? In your last project, right? If you just did a linear search, then with millions and millions of records, then it wasn't going to execute in maybe even a day. But if you sorted things and then searched through it using what? Binary search, it suddenly became extremely efficient, right? Exponentially more efficient. The database works the same way. If you don't have good normalization, you may not have indexing. In other words, the database can't sort records and efficiently search through them using, that doesn't use binary search, it uses trees that we'll talk about later. It uses B trees generally, or some other efficient data structure like that. But if you don't have a well-designed database, it can't exploit those algorithms, it can't exploit those data structures in order to give you that performance. So make sure that you've got good normalization. And at this point, I want to go to the website here. Let me, modules. Because everybody posts the XKCD the comic, but I think it's even more important to read a comic like this. I'm so glad that somebody put this comic together. It's called Commit Strip. And I'll go ahead and zoom in for you here. So one of them is, I think we've hit a MySQL limits. It's simply too slow. Let's face it, the amount of data is colossal, right? So I was thinking we should switch to NoSQL. All right, let's throw out relational database management systems altogether and use MongoDB or Redis or something like that. I prepared a 3-month battle plan. Here, look. Frameworks, refactoring, training, workshops, internal tool updates. Wait a minute, let me check something. And I can't tell you how many times this has been me in the past. Just as I thought. Here you go. It's called an index, and it just made your queries 20 times faster. dude, missing indexes, seriously, right? So that is probably going to be a lot more useful comic for you going forward to cite to other people. Anytime you see a poorly designed database where you don't see indexes, where you don't see proper primary keys and foreign keys, and bad practices like using varchars or something, you can immediately go ahead and post that instead of the stock XKCD. Right? So those are efficiency issues. The notes have a bunch more resources, but one other thing that I wanted to talk about is logging, right? So not logging as in cutting down trees, but in a real system, no one is sitting at the terminal looking for failures, right? Meaning that, like when you ran your web app yesterday and again next week, what if something goes wrong, right? Are you going to have somebody sitting at the terminal 24/7 looking for stack traces and going, oh, something happened, the stack trace is there, I need to go ahead and jump into action, start coding right away? No, that's a bad idea. But you do need that information. You need the information of what happened. Like there was a crash somewhere. We need that stack trace preserved somewhere so that, okay, tomorrow morning I'll go ahead and take a look at the stack trace. Oh, here's the bug. I found the bug. Check in the bug. Push to production, right? You do need that information. But the standard output is not a good way to do logging. The standard output is insufficient, right? No one is sitting at the terminal monitoring it, right? Instead, you need real logging. Real logging, real system logging involves, right, output or logging information to files or databases or something else, right? If it's you can have a logging system such that if there's a severe enough event that gets logged, you can also go ahead and push that out to an email to the system administrator. This happens all the time with systems. I've had several web apps running on CSE before, and I'm not an administrator, so I don't have access to the tools that I could set up to tell me your app is down, by the way. So I just set up a cron tab and a script that checks it every hour or so. And if it gets a 404 error from the web page, right, the web page not found, then it goes ahead and emails me, and then I email the proper people and let them know something's wrong with the web app right now, right? So you can have a logging system do that kind of stuff for you. Generally, a good logging system has a lot of features, right? Daily or size-based rolling files. You don't want just one gigantic file holding all of your logs for all time, right? You want to log all the information within a 24-hour period, and then at midnight it says, okay, I'm done logging to that file. Next day, new file, right? And then you can keep, it's rolling in that you can just keep the last 10 days or last 20 days. Or if you want to keep them in perpetuity, that's fine too. It gives you a way that you can diagnose problems in the past. It gives you a way that you can log certain events, like this person last logged in on this date, right? I've done this with the WebGrader before. I look and see how many times did you run the WebGrader before it was actually handed in, right? 0. Oh, well, then you know that it wasn't working, right? And so you've got logging information like that. Very, very useful, right? And with a proper logging system, you can have all these features built into it, right? Logging provides valuable debugging information, like it provides data like login data, metrics, right? How many unique people have visited our website? Are we getting a bunch of hits from a foreign IP address over and over again because they're trying to probe our system? That happens all the time. Metrics, auditing info, etc. Right? So for Java, there are lots of options. The most recent versions of Java have a Java logger built in, so you might want to check that out. But I'm going to go ahead and show you log4j. Because this is worth bonus on not this assignment, but in the next assignment or two. So let me see, where was I working here? This is snow day. Where's JDBC here? So let me go ahead and open up the director here. Now, normally, if you encounter an error, right, I'm going to go ahead and throw this runtime exception. And let's go ahead and let's do this one instead, though. So if we have a bad user or a bad password or something, let me go ahead and get rid of my password here. Right? Now, obviously, this is not going to work. So when this happens, let me run it. You'll see that, well, it output to the standard output. Once I close Eclipse, or once I get rid of that standard output, it's gone. There's no record of it, right? And I didn't test this before we got here because I didn't have time, but I will show you how you can do better than this. Instead, we're going to log information here. Right? Now, to do this, I'm going to have to download and install Log4j. But since we don't have time to do that, and I didn't do it beforehand, let's go ahead. I'm going to show you how to use Maven, right? Maven Central Log4j. Right? So if you look up a package that you really want to use, this is good. I'll go ahead and grab the latest version, say. Right? And there. All you need to do is cut and paste this into your project, POM, your project object model, I think it is, right? And I'll go ahead and cut and paste this here, right? So I want to use Log4j 1.2.17 and Maven dependencies. Hey, what did it do automatically for me? It downloaded and installed that jar file for me. Now, if I build it, I haven't tested it, but if I build this according to the instructions I've given you, I hope that it will also build it with that jar file. If not, then I'll go have to manually download it. But now I've got a logger, right? So let me go ahead and log. And for this, I'm going to have to remind myself. Yep, I'm going to give this class a logger, a public static. I think it's a logger, right? Log is equal to new, or no, sorry. Let me go ahead and find out where it is. Import Java, so there's java.util.logging. That's the newest one. You might want to use that. So then you won't have to download anything. But this is the Apache Log4j one. And I'll go ahead and create a new logger, .get logger. This class is director.class. Right? And now I've got a logger here automatically for me. Right? And down here, I can go ahead and log to the log. Right? What is that log logging to? I don't know. Right? Log.error. Right? And I'll go ahead and give it a message. Could not connect to the database. And I'll go ahead and keep the SQLE stack trace in there for it. Oops. Undo. There we go. Now let's go ahead and run this and see what happens. Right? So it's still going to the standard output here. And Log4j was not able to initialize itself. And that's because, well, you have to set up a properties file, or you have to set up a configuration first. But the easiest way that I've found to do it is if you don't care about the way that your logs look, then you can do basic, in your main, you can do basic configurator.configure. And this gives you, yeah, there we go. This gives you a default setup. So let me go ahead and run this. And now you see that it was repeated, right? Yes, it's still going to the standard output. You can set it up so that it no longer goes to the standard output, or you can redirect the standard output to a file or something like that. But this is what I really want up here. It looks a bit different, and that's because it is. It tells you, I think that this is the number of milliseconds that have passed, or the number, I forget what the number is. It tells you the function that it occurred in. It tells you the error level. Remember, I did log.error. There are other things that you can do. For example, if you just want to log some basic information, like retrieving all the directors, log.info, retrieving all directors, ... right? Then you can log some information to your logs. You've also got log.warn, right? Warning for some reason, right? There are several layers of log messages. You can have debug log messages. Log.debug. OK to here, right? Now you're back at square one with poor man's debugging kind of stuff, right? So you've got several different layers that you can, or several different priorities that you can have. Then in your configuration, you can say, OK, well, for the purposes of deploying to our test server, I want you to log everything. I want you to log debug information all the way up to error information. But when we actually go to production, I don't want that debug information anymore. Only go ahead and log the warnings and the errors and maybe the information or something like that. Also, I want a size-based rolling file appender so that at most every file is at most 100K. And then it starts another file. And then it starts another file. And I want you to keep the last 50 of them. Right? All those things, all you need to do is install a logging system and then put that into a configuration file. And you've got all those features for free. Right? It's much better than going to the standard output. In a real system, you would never, ever see system.out.println or something like that. Okay? All right. Yep, that's good. All right. And I don't, I'll leave this open just in case we need it. But there's Maven Central. All I did was Maven Central, MVN, a repository. And I don't know, what do you want to look for? One thing that I've got installed is Bouncy Castle. That's a cryptographic library that you can do a bunch of cryptography with. And to download it, well, there are several of them here. Popular, newest. I don't know which one I would want, but probably this one. Right? And to download it, all you need to do is cut and paste that XML into a POM file, and it automatically downloads the dependencies for you. Right? Okay. Questions on JDBC so far? No? Then with our last 30 minutes here, I'm going to give you an end cap to basically the first half of this course. Let me pull it up here. Right. Because in the second half of this course, we're going to focus more on, I remembered my quick key, good. The second half of this course, we're going to focus on data structures and algorithms. Data structures and algorithms that you can then go ahead and integrate into a real system that you're producing, which you will do. You'll design a sorted list class. But I want to wrap this up by talking about basically what you did yesterday, right? What is this war thing that we're producing? What is Glassfish? What is all this kind of stuff? And it's an instance or it's an example of multi-tier architecture. Now, you started at the very bottom where you were just doing basic functions in, say, in C last semester. And then this semester is a little bit different because you're designing an actual multi-tier architecture system. You start off by creating your middle tier, your classes to model the problem. Then you move on to the interaction of classes and how they produce a solution or how they produce a report. Then you build the bottom tier, the data layer tier. And then you integrate that so that your middle tier is then displaying information. You don't actually, in this course, you don't actually get to the front end. Well, your front end is nothing more than you printing out the statements, right? But you've seen a preview of what a front end would look like in your lab yesterday. When you deploy something to, say, a web app, then you've got a web page that you can interact with your middle tier. The middle tier then interacts with the database. The middle tier pulls information from the database and then displays it in the front end, right? And that's what basic middle tier, multi-tier architecture is all about. Again, up till now, you've done mostly small or text-based files. You've run things locally. This is what you did all last semester. You may have done some thick GUI stuff. That is like GTK that you did last semester. Or if you've ever done Swing or JavaFX or even mobile applications, those would be considered thick GUIs as well, graphical user interfaces. There's little to no interaction with other programs. But that's not how the vast majority of software actually works. The vast majority of software is built to interact with other software. So that System A can talk to System B, so that System C can request data from a database system, and all those systems work together to then finally produce a report, or maybe they don't do anything at all as far as a human interaction is concerned. We have kind of a warped sense of what computing actually is until you actually get into it, that well, yeah, my phone, that's computing, right? My desktop apps, that's computing. The vast majority is not that. The vast majority of software is actually behind the scenes, running automated, and there's no human involved at all. That's the whole point of computing, to eliminate the human factor so that we don't have to do all the grunt work anymore, right? And so real systems require larger scale stuff. make extensive use of databases. They're distributed, they're multi-user, and by user, I don't just mean a human user. I mean another client, right? Another computer, another program, right? And you can organize responsibilities and interactions into tiers, right? Because once, and forget about that for a second. Yep. So what you've been doing up till now is a single tier, say last semester was just a single tier system. But once you get into a more complex system, once you get into a complex application, then you just have way too much. Remember we talked about this with respect to object-oriented programming, where if you just have one class and you throw everything that you want into that class, it becomes the God class. It knows everything, it sees everything, it does everything, right? We don't want that. That's an anti-pattern. We want to split things up into different classes so that we have some organization, a separation of responsibilities. When you get into an application that is more and more complex, then you need to do that at an even higher level. We can't just have our Java program do everything for us. We need a database that knows how to do database stuff. We need a web page and a browser that knows how to display information to a computer rather than that standard output kind of stuff, right? Nobody likes looking at a green screen anymore. So applications with just a single tier that you've been working on up till this point, or before this class, would be installed programs, thick clients, right? The Adobe Acrobat Reader that I'm playing right here. Oh, Winamp, I still have that, that reference there. Anybody ever use Winamp? A music player? All right, well, now everybody uses their browser, and no, Spotify has a thick client application, right? You actually download that application and install it. That's a thick client application. But if you're listening to Spotify or Pandora through your web browser, that's different. That's a thin client, right? Microsoft Excel, or they're usually single users, terminals with a networked file share, et cetera. And so you have one program that is responsible for everything. But at some point, you need to realize that this is getting too complex. So you start separating responsibilities out into two tiers, where you have a client and a server architecture. Spotify is an example here. Spotify, or Pandora. If you've got a web-based application that is able to play Pandora music, not all the music is stored in your web browser. Your web browser goes out to the server where the music is actually stored and transfers it back and forth. And then every so often plays a commercial for you, right? And so you have different responsibilities. You have a client-server architecture. And so you have this, you have a demarcation of responsibilities. That down here, the database is responsible for storing those songs or storing the database. And then the client tier is responsible just for displaying or actually playing the music instead. You can go even further, though, where you've got three tiers. And this is generally what is done in practice. You've got, sometimes it's called MVC, Model View Controller Architecture. Anything that separates it into three tiers, you can call it three-tier architecture, where you've got a database layer, you've got a middle tier that's responsible for all the business logic, and then at the end of the day, you've got this this presentation layer or this client layer where you can actually display information to the user. And that's what you did yesterday. At this point, I want to jump ahead to show you what that looks like. There we go. All right. This is kind of what you were doing yesterday. You've got that database, right? The albums database that you installed that we created for you. And then you've got Java classes that are reading and writing from the data from the application. It was actually doing an HTTP GET request. We wrote the JavaScript that we wrote for you was actually making a HTTP request to your Java files. You were responsible for the Java files. The Java files were the middle tier. The application, which was the HTML, JavaScript, CSS, et cetera, I think we used jQuery as well. That was the presentation layer. That's what you actually see as an end user. But there's this whole other, there are two whole tiers behind that. You were making HTTP GET and HTTP POST next time when you actually put stuff into the database. Requests. This is all being done through what are called servlets in Java. And if you want to, you can go ahead and start taking a look at what those look like. Otherwise, the application yesterday was just a bunch of CSS, HTML, et cetera. You can imagine that you can go ahead and separate. I never mentioned any particular technologies here other than HTTP. You can have an application that doesn't just go to your database. You could, orthogonally, it also goes to other databases. For example, you can have an application that goes to your database and gets information about school activities, and then it goes out to another web application like, say, Google Maps to map those activities where those they're located. You can have another another one that goes out to a financial services database and pulls the most current stock reports and then puts that in, right? You can have your application spidering out onto the web using a bunch of different applications, right? So that's basically, we didn't do that, of course, because we were just getting album information. If I could ever find an album service or something that gave us metadata on it, then yeah, I'd do that. But otherwise, this is a three-tier architecture here that you were using yesterday. Right? And let me go ahead and jump back here sorry. Yeah, so these slides, I'll also be open about it. These slides were written in at least 5 years ago, at a time when it was kind of the Wild West as far as the web was still concerned, as far as APIs go. Now everybody, even public APIs, have locked their public APIs down with an API key. For example, I did a demonstration the other day in another section where I was I wrote a Java program to connect to Imager. It's a photo sharing website, right? And to do that, I had to sign up. I mean, it was free, but I had to sign up to get an API key, and then I had to use an API key just to get public information, right? And so it was a big hassle. There's not a single open API out there anymore that doesn't require you to register and get an API key, simply because they don't want you making 1 million requests to their website. They want to throttle you. Once you make 1 million requests, okay, you've had enough, right? They're going to cut you off. And then using your API key, they're able to identify that you're the one doing it, rather than just relying on IP address or something, right? So again, a three-tier technology looks like this, where you've got a database, a middle tier, and a client tier. The advantage here is that you can separate these things out. You've got a very, very complex system. If you're able to layer it, now each layer itself is not as complicated as before. And if you've got a very, very large application serving millions and millions of users, and you've got dev teams of 20, 30, 40, 100 people, then you can start separating them out into different tiers, and they're each responsible for a different thing. One developer no longer has to be responsible for everything in the entire application. They only have to be responsible for their smaller world over here, right? And that's one of the big advantages of separating your stuff out into tiers. And of course, there are lots of different technologies. You could have a SQL server acting as your data tier, or Postgres, or Oracle, or MySQL. You can drop anything that you want into there, and that's your data tier. Right? Middle tiers could be C#, .NET, ASP, JSP, Java, PHP, for example. You can even do stuff in C++, Perl. Any language will have some sort of a middle tier kind of structure that allows, and there are dozens upon dozens upon dozens of these things. You've got different frameworks like Rails, or my favorite website to go to anytime somebody asks me, or anytime somebody says, let's do some JavaScript. Oh, I really want to do, say, Angular. I go, okay, fine. Or well, have you considered, let's see, all I need to do is give them this website. What do you want to do? Right? There are no less than a dozen, plus 2, plus several others, different JavaScript frameworks that you can use, right? Or you could just use what's called vanilla vanilla.js, which is just regular old JavaScript. Just write the damn code. You don't need these fancy things, right? And anytime somebody suggests Angular, you can even go further. Oh, do you mean Angular 1 or 2? Or maybe 3 a year from now, right? None of them are compatible with each other, right? So the JavaScript world is truly a Wild West because there's just way too much out there. And I'm sure that there's even more niche kind of frameworks out there. So there are plenty of options here, is what I'm trying to get across. Thick clients like Java, you could still write Java applications. It's not at all recommended, but you can. As far as Java applets, Java applications are still very, very much alive. Eclipse is a Java application. I believe IntelliJ is written in Java, but I'm not sure. You'd have to look that up. Other things like what's the best torrent client? Say what? uTorrent? Okay, I'm not aware of that one. Is that the Blue Torrent or something like that I used to use? Okay, well, there are plenty. The one that I used to use was written in Java, right? And it was a thick client application. Nowadays, I would recommend that you go with Java FX. For the last 10 years, that's been the de facto standard, not Swing. Or, over the last 5 years or whenever they introduced it, if you're doing iOS application programming, you're no longer using Objective-C, you're using Swift, exactly, right? Or you can have thin. You can decide, well, we want a thin client instead. We want to support a web app. So it's browser-based. There's cross-browser compatibility issues. Do we want to use Angular? Do we want to use Backbone? Do we want to use Ember? Okay, you can debate yourself. You start going down those paths of using those things. Vendor lock is what is your end goal there. Now we've got 1,000 pages written in Ember.js or React.js or something like that. We're not changing anytime soon, right? But there are also in-betweeners. MS Silverlight and Java applets are essentially dead. Flash is essentially dead. So I would amend this. The latest attempt here, well, actually there are two latest attempts here of in-betweeners where you can write it once, compile it once, and run it anywhere. The first one would be Electron. Have you ever heard of Electron? It's basically you write your stuff you write your web app in JavaScript and whatever else you're using, and then you compile it by rolling it up into an Electron application. Basically, all you're doing is you're taking an instance of Chromium, in other words, a browser, and then you're taking out all the browser features, and then you're packaging only your application in, and you're distributing it. I tried it one time, and the first thing I do, of course, is to do a Hello World program. The compiled Hello World program to just display Hello World was 300 megabytes. Yeah. So that's the biggest gripe with Electron. That's what happens when you package up an entire browser into an application just so that you don't have to have a web app, right? The other thing that I would mention here is something that is hopefully going to be on the horizon. I've been saying this now for the last 3 years or so, though, is ASM.js or Assembly.js. I don't know what it's called anymore. They keep changing the name. But basically, it's a small sub-language of JavaScript that is a target language for other languages. So basically, you could write your application in, say, C++ or Java or something like that. It'll transpile it to JavaScript. And now you can write your application in whatever you want and have it run on any browser that you want. It's its first name was ASM.js, which is assembly machine for JS. I don't know what it's called anymore. Do you? Yeah, and that's generally called transpiling instead of compiling, because you're not compiling it to machine code. You're translating it to another language. And you can do that. In fact, you do that with JavaScript itself. You transpile JavaScript into older JavaScript to be compatible with older browsers. And if you've got this brand new shiny feature that was introduced in ECMA script 15 or whatever, and you want to use it, go ahead and use it. Run it through a transpiler, and now older browsers that don't have that feature, you can have that feature now, and still run on older browsers, right? And then, of course, RESTful services. REST is representation state transfer. Basically, it's just how stuff CRUD, create, retrieve, update, and destroy, but via HTTP. You can say, destroy that record, insert that record, and it's all done in HTTP rather than, and then what's on the back end, it could be a database, it could be something else entirely, right? It's easy to go even further. And if you've got a really complex system, you can generalize it into n tiers, not just 3, right? It might be for scalability. It might be for, well, we don't have the infrastructure to serve a huge database. Let's go ahead and have Amazon Web Services do it for us. That gets into software as a service. You can have software as a service, platform as a service, Docker or something like that. Networking as a service. You don't have you need a bunch of bandwidth. That's usually done by, you're not going to build your own networks, right? You're going to go on piggyback on whatever networks are there. And IaaS, which is infrastructure as a service. Virtual machines. You don't want to have an entire server farm because you're not big enough. That's fine. You can pay Amazon Web Services a monthly fee instead of that huge investment of hundreds of thousands of dollars in equipment. You just go ahead and rent it, right? To do that, though, you need to separate out into tiers. What tiers are we going to be responsible for, and what tiers are we going to outsource to AWS or whatever? Yeah, an example would be, say that we have a database tier, and then we got a data access tier where we don't want to write our own JDBC code. Instead, we'll use like JPA, or if you're using .NET, you can use ADO, which is Access Data Objects. I'm not sure. I think that's what it is. Then you have, like, say, you have multiple business tier layers. You could have a core business layer tier. Say if you're, and I've seen this before with banking systems, where somebody builds a banking system and then they want to sell it to 10 different banks. Well, there's some core functionality that all the banks will share, and then you can have a second level where you provide customization for each bank. Or you can provide customization and then say, well, yeah, you can buy our product here and then sell them the core product for very, very low. And then once you've got them hooked, you can say, oh, by the way, we've got these other business tiers that we could sell you that do reporting, that do customer interventions, whatever. I don't know. I'm not a business person. But then you can start selling those other customized things, right? Then you can have a validation layer where all data going between those layers is validated. Then you have a presentation layer or a templating layer where you have a basic presentation layer that's common to everybody, but then Bank A, of course, doesn't want Bank B's icon there, so you have a templating layer where you can replace the icon with Wells Fargo over here with something over here instead, right? So you can have, and you can go further than this. This is just I just chose this because it was 7 layers, right? And everybody loves 7-layer burritos. Actually, it's because I worked on a system that had this architecture already, right? You have natural questions when you get into this kind of stuff. How many abstraction layers should we actually use? Who should be responsible for what? Thick or thin clients, right? Web apps, do we want to support web apps and Android and iOS, right? How to manage data, which languages do we choose, which platforms, which technology. If you want to use something brand new and shiny, I don't know, if you want to do everything in Rust or Haskell, you're going to have a hard time finding a lot of developers, right? Because that's either a new language or it's a niche language, respectively. Whereas you've got a bunch of Java developers, you've got a bunch of C# developers in the area. Probably want to go with those instead of something niche because you're not going to find anybody and hire them. And if they leave, there's a classic example of this is at my last job. They were still on not an AS400 system, but they were on a green screen system that used not COBOL. What? No, not Algol. It was RPM. That's it. It was an IBM language that is all but dead. They were still using it because they didn't want to pay to rewrite everything in a more modern language. But guess what? How many RPM programmers are out there? Not many. So they were continually offering, running job offers or job listings for RPM programmers. Because as these people retire, then there's always a niche area that you can get into. Learn a dead language, and you will have a job for as long as somebody doesn't want to. For as long as you are cheaper than rewriting anything. There are lots like that. COBOL would be one. Another one would be it was an Adobe Acrobat product. What was it? Not Acrobat, but Adobe. Say what? No, not Shockwave. I forget what it is, but you still see job listings for it because they have applications out there that still need to be supported. They're still adding features to their application, but nobody knows those languages anymore, right? So those are all factors that go into your decision-making process for all of this. Right? Also your user base. Most startups think that they're bigger than they ever are, right? We need we need to buy $100,000 in equipment. When you've got 100 users, no. Go with Amazon Web Services until you grow out of that. Go for the cheapest things until you grow out of it, and then worry about it then. Right? That's a good problem to have. If you never grow out of that, then that means that you're not growing. It's not a success. Right? Only when it's a success is that a problem that you have to worry about, and now it's a good problem because it means that you're successful. Your startup was successful, or your company is being successful. This is the iron triangle of project management, or it's not just in computer science. Correctness, quickness, or cheapness. Choose two, right? Meaning that if you want to do it correct and you want to do it quick, it ain't going to be cheap. If you want to do it correct and cheap, then it's not going to be quick. If you want to do it quick and cheap, then it's not going to be correct, right? This is the iron triangle that you can only select two of the areas at once. And you're never going to have something that is both correct, quick, and cheap. Right? You'll never get that. Also, you might have new requirements. If you do grow out of your current requirements, the design might need significant changes. You may need to go in and refactor things. In other words, you're not changing the functionality, but you're changing it to be more maintainable, or you're integrating new technology to make it more efficient. And many of you might be doing that with your code base right now. Even from phase 1 to phase 2, you found some mistakes, or you're fighting your own code. Throw it away, or refactor it so that it has the same functionality, but it's much easier to work with. You also have to deal with migrations, moving from an old server to a new server. How are you going to do that? If you've got a sufficiently complex system, that could be several weeks of planning, or it could just be a flip of the button. It all depends. The good design has loose coupling, so that if you want to replace your database tier completely from SQL Server over to Postgres because you no longer want to pay for it, then there needs to be loose coupling. If you can't simply take out this database tier, throw it away, and replace it, and it affects stuff up above in the higher tiers, then you don't have loose coupling. That is a bad design, right? Because you're not able to throw those things out. Again, good modularity, interoperable standards. Don't go your own way. JSON, XML are still very much alive and well. WSDL, not so much. ECMA, that's the JavaScript standard. XML is always going to be there. Right? Leaving a system easily extensible, upgradable, and updatable, that's good design. Bad design is where you don't have those things, where you don't have a demarcation of responsibility. You've got business logic stuck in your database tier, or your middle tier is for some reason generating presentation layer stuff. Like you've got Java files that are generating HTML or something like that. And so when you've got this, there is no demarcation of responsibility. Now everybody is responsible for the entire stack. You have to know how things are done in the presentation layer just to worry about data down here, right? That shouldn't happen. You shouldn't have, bugs are harder to track down. DBAs should not have to be application programmers and vice versa, database administrators. And all of this stuff incurs what's called technical debt. Technical debt, or it's also called a naked call option if you know anything about stock bets, right? A naked call option is basically where you are saying 10 days from now, I will pay whatever Google stock. I will buy 100 shares of Google stock 10 days from now from you for whatever the market price is 10 days from now. I'm making a huge bet there. I'm making a bet that 10 days from now, Google stock is going to be significantly less. What happens if they announce a brand new product that shoots their stock up 20%, right? I made a guarantee that I was going to buy that stock from you. That's a contract, right? It's called a naked call option. I have to pay you, or you start litigation against me. That's what technical debt is. It's taking out a loan without knowing how much you're taking out and without knowing how much interest you're going to have to pay. You're not taking out a loan on money. You're taking out a loan on your time. Remember one of the mantras of this course at the very beginning? You'll have to find time to do it right, or you'll have to find time to do it over. Right? And that's exactly what bad design gives you. Right? Not thinking about that design up front can be very, very costly at the end. In fact, you don't even know how much it can cost because it's a naked call option. Right? Successful design requires good design, appropriate resources, competent developers, motivated developers. If you just have your senior developers working on yet another CRUD application, they're going to get bored. And bored people tend to make mistakes, no matter how experienced they are. In fact, you should be motivated. It is usual in the software development industry to change jobs every 3 to 5 years. Generally, that is the only way that you will ever move up in the ladder. That is the only way that you will ever get raises. There's always what's called an inversion of salary in the industry. In other words, the people that are being hired today are probably being hired at the same salary level as people that have been there 5, 10 years, right? Do not rely on employers to, oh, good job, and pat on the back, and here's your raise. They'll give you a pat on the back, but they won't give you the raise. Go into this thinking you might love a job and want to stay there, and if the pay is fair, great, go ahead and stay there. But always be looking at your options. One of my colleagues, just as a general rule, always sends out his resumes every year, even if he's never going to take an interview or anything. Sometimes he goes on interviews every year just to see what it's like at another company. He's been at the same company for 5 years and still has no plans for leaving, but he still explores his options, right? And that also keeps his own company on their toes, because he'll tell them, yeah, I'm taking an interview next week. Oh, okay. Maybe we should do a performance review too, right? That's the only, be adversarial, right? There's no such thing as a benevolent company that's going to give you what you're worth. You're going to have to make sure that you're getting what you're worth, right? Don't worry about model view controller. It's just another way of looking at a 3-tier architecture, and that's basically what you were working on. Just to wrap this up, this is not a software engineering course, but we've touched on many software engineering principles and ideas that you'll eventually get to in a more formal setting, including methodologies. Waterfall is a method where you basically design the entire system up front. And then you say, we've got these 5 phases that we're going to go through. What happens if you get to phase 4 and you find out the design was flawed? You go all the way back to the beginning, right? That's why waterfall has fallen out of favor. Instead, what you're kind of doing is agile, where you have what are called sprints. Every 2 or 3 weeks, you have a design document due, and you have a phase of the project due. Those are basically sprints. Usually a sprint is more like 4 weeks, or there could be half sprints, which are 2 weeks or something like that. Basically, at the start of a sprint, you decide, what are we going to do? What are we going to work on for the next 4 weeks? Once the team has decided that and estimated that, yes, this is doable within 4 weeks, then you commit to that work, and you work. That's all that you work on in that sprint. You don't have a manager coming in and say, drop everything you're doing, context switch, and do this thing over here instead. That's not how agile works. Basically, it's a software design and methodology that protects you from bad management. It's self-managed teams. Then at the end of the sprint, you deliver what you have, and then you go back to the client or the stakeholder and say, here's what we've got. Look good so far. Oh, actually, our requirements have changed. Okay, great. Thanks for telling us. We'll go ahead and redesign that for the next sprint. It chops it up into smaller chunks. It's more agile. It's more flexible. Rather than deciding, here's the design up front, and we're going to commit that for the next year or 2, right? No, because if you get to the end and it doesn't meet expectations, start all over, right? That's what waterfall is. Kanban is another way of doing this. You'll eventually have Kanban boards where you can you put up tasks on the Kanban board, and then you take down tasks, and this is what I'm working on right now. It's more at the individual level. And then once you're done with that task, you put it in the done pile, you go back to the Kanban board and say, I'm going to work on that task next. And it's a way of managing a team, to know exactly what anybody is working on at any one point, and to know that everybody is pulling their own weight. Because you can go to the Kanban board and say, okay, well, George over there is working on this thing, right? I'll go ahead and work on this thing. And then if he ever hits a snag, you can go back to the Kanban board, put it back up, and say, I'm taking 2 vacations because I'm too stressed. Okay, that's all right, we'll take your tasks for you, right? There are always business requirements. Design and requirements, the fancy word that they use for it is elicitation, requirements gathering, where you need to go to the client or the stakeholder or whoever is paying the bills, basically, and ask them, what do you actually need in this system? We kind of prescribe that already in our project overview, but that basically, in the real world, you're not given a project overview. You have to go and interview the clients and say, all right, what are your needs? You need a system to replace this system over here. You need a system to automate this stuff. We need to understand your processes so that we can emulate that, or we can make it better or something. Those are requirements gathering. Design specifications, use cases. Well, how are you actually going to use the system, right? Is it just going to sit there and no user is ever going to interact with it? Or Phyllis over there needs to have access to these reports because it's part of her job. What are the use cases for this? Testing and QA. Unit testing, integration testing, automated testing, regression testing, performance and load testing. There's testing at every single point along the way. We got into unit testing last semester. You used CMACA for unit tests. In Java, maybe you've been using JUnit, I don't know. Or at least you've been doing ad hoc testing, hopefully, right? Not just relying on the web grader. Integration testing is where you've got, which you're going to be doing next phase. You've got a database and you've got a Java application that models the problem. Now you need to integrate those two. How are you going to test that? We'd like to see that in the design document. Load testing or performance testing. How well is our virtual machine going to hold up to 1,000 simultaneous users, right? We need to simulate that in order to see if it works. Netflix has invented a new word for this. You might have seen chaos testing, or there's a product called Chaos Monkey that is intended to inject chaos into a network system and see how resilient it is. And Netflix does this. It's basically just load testing, but they call it chaos testing for some reason. Version control systems. CVS don't even think about that anymore. Even SVN don't think about that anymore. The winner clearly is Git. You should be using Git on your projects, especially if you're working with somebody right now. You've teamed up with somebody, use Git. Use a version control system of some sort. We covered that somewhat last semester. You've used that every single lab that you've been using, and it's extreme. Next to debugging, I'd say it's just as an important tool, right? That you need to use and understand. If you want to get into it, you can do build systems and deployment systems and management systems and dependency systems like Maven that I just demonstrated. Ant and Make are build systems. Make you used last semester, even though you didn't write your own make files. We gave you make files. It simplified the compiling process, right? All you had to do was type make, and all the rules were done for you. All the dependencies were done for you. Writing a make file or writing an Ant file or writing and creating a configuration file for like Maven, that's an entire job in and of itself. They call them continuous integration engineers or deployment engineers. And that's like one person's entire job is just making those files and ensuring that deployment happens. In fact, at the last place I was at, we had 150 developers, and we had 3 of those people. That was their only job, was maintaining and creating deployment scripts and build scripts. Right? There are also legal and ethical issues. Intellectual property. Can I use this library? Do I have to pay somebody? Is somebody going to be knocking on my door and suing me because I've used their stuff and I've sold it? Right? You need to understand all that stuff. Privacy. The big boys don't care about privacy, but you should. Right? Also, you have things like Sarbanes-Oxley or NIST, National Institute of Standards and Technology, and a lot of other issues. The bottom line here is that a software developer or a software engineer needs to be a lawyer to an extent, needs to be a philosopher to an extent, needs to be a diplomat for those soft skills, working in a team, working with other people. They need to be a designer. They need to be a manager, especially if you're going to be in a self-managed team. They need to be a writer, and at last, they need to be a programmer. Over the last over the last semester and a half now, you've been focusing on the bottom one there. That's actually going to be, if you go into industry, that's actually going to be a very small part of what you do, right? I can tell you, my last job, I think 10% of our time was spent in meetings, and they weren't all, bad meetings. It's not like we were wasting time and spinning wheels. It was requirements, going to clients and talking to them and saying, what do you need? Or review this system with us. Is everything okay here? Meeting with other teams, because that team that our code depends on, they're actually making a change next week. So we need to meet with them and understand their process, how they're going to change things so that we can change things on our end to accommodate them, right? Meetings are not bad. Meetings, or they don't have to be bad, I should say. They can definitely be bad. They can eat up a huge chunk of your day. But the point I want to get across to you is that programming is actually going to be probably at the end of the day, that's probably going to be a small part of what you do if you go